welcome everybody to our webinar talking about a little bit about the Databricks Lakehouse and of course the foundations with Databricks SQL. Just a little bit about Newcomp. We have been around for a long time, 25 plus years in the Canadian analytics space, but what we do is we specialize in analytics and departments and industries in Canada, the US, and the Caribbean. We help our clients tackle most of the challenging data projects that they have. So in order to do that, in order to, of course, serve our client base very well, we tap into several key partnerships, such as the one that we have with Databricks, in order to do that. Next slide, please. Newcomp's DNA is, and our pillars, we have 5 of them, are quite based on what we now see in the cloud space, right? So we have a practice in data engineering, BI and data visualization, of course, but then in turn as well, we've been doing a lot of work on the AI and machine learning space. On the other side of the pillar, on the other side of the spectrum, more so, we have a division concentrating on financial planning and analytics. And then, of course, to support all of this is our cloud division. So your presenters for today are myself. I'm Sebastian Richter, so I'm a data analytics lead here at Newcomp and Databricks, and I'm joined by 2 wonderful human beings from Databricks. So Ricardo, if you want to introduce yourself first.
Hey everyone, thanks for your time today. Ricardo Piscatelli, Enterprise Account Executive for Databricks, based out of Calgary, covering Southern Alberta and BC.
And then we have Andre.
Hey guys, I'm Andre. Excuse me. I'm a solutions architect at Databricks. I'm also based out of Calgary, along with Sebastian and Ricardo. So it's nice to meet everyone. So today, as you're all aware, we're here to talk a little bit about Lakehouse and specifically what Databricks SQL is in context to that design paradigm. So we're going to break this up into 3 sections. So first is going to be a quick 101 on what is Lakehouse, why did we at Databricks develop the Lakehouse paradigm, and what business problems does it solve. We're also going to cover a little bit about one of our more recent additions to the Databricks platform, which is Databricks SQL, how it impacts business analytics and business intelligence, what Photon is specifically, and then finally at the very end, we're just going to have a brief non-interactive demonstration of what it looks like in action, doing some basic ETL, ELT, navigation of the workbench, and basically how to put together a dashboard. So Rico, off to you.
Great, thanks, Andre. All right, everyone. I'll take the first 10 minutes to give a high-level summary of Databricks and Lakehouse architecture. First off, I'd like to apologize. I'm not on camera. Unfortunately, my MacBook is not being friendly today, so apologies for that. But certainly, really appreciate you taking time. So who are we? Who's Databricks? So, we're founded in 2013. Majority of people know us from our association with Spark. Our six founders came from the Berkeley Amp Lab. They're self-titled hippies, looking to change the world, and who invented Spark and brought it to market. And as they were meeting with organizations, they realized they needed an enterprise wrapper with proper SLAs and support. As it was hard to get these large companies like Apple and whatnot to buy into an open source without having that kind of enterprise class support mechanism behind it. So. But they didn't want to end with Spark, and as the data and AI space is constantly evolving. So, through a culture of innovation, they drove additional open source projects like Delta Lake, MLflow, which hard to believe, but has almost 2.5 million downloads a month. So the core of what we do is everything is founded around open source, open standards, and making them available to market. And then what we do is we wrap it up with a unified managed service and serve it up at enterprise scale, so that organizations that aren't the Netflixes and Airbnbs, can manage a wide open source environment. We enable enterprises to get, take advantage of modern data state, across data and AI without needing, hundreds of developers that some of those Silicon Valley companies would have. So we work with over 5,000 customers across multiple verticals, household names as well as industry disruptors. Some of our clients are digitally native in how they were founded, so the transition is a little bit easier. But certainly, the lion's share, and especially for those of us working with customers in Western Canada, there's a massive transformation happening both into cloud and then with analytics. So we spend majority of our time with those kinds of customers. So next slide, please. We talk to a lot of customers and the history of their data platforms, and by nature, it's resulted in this kind of siloed diagram you see here. Most organizations start off on the left with an on-prem data warehouse with structured data for reporting and BI work, and it does a great job, but there's limitations in terms of new data and use cases, things like streaming, unstructured data, and semi-structured data that just it struggles to drive value. So most customers then introduced a data lake and started to try and glean insights from the rest of their data, which resulted in a separate silo or architecture. And we're seeing more and more requirements for streaming analytics, especially for many of my utility and energy clients. Meter readings, IoT sensors everywhere. Needing real-time response, for things like anomaly detection. So this too requires its own separate architecture based on where the other two are. And then finally, with new opportunities from the business and data scientists, things like customer segmentation, revenue forecasting models, customer lifetime value, we've got yet another list of use cases that need to be supported and resulted in a separate kind of stovepipe architecture. So the end result is customers struggle with siloed data, multiple copies of the data, groups that don't interact with each other, and a bit of a spaghetti mess. So, in this scenario, what's the most accurate data? What's the most recent data? And why is it that when, an executive asks a question, they get 3 different answers from 3 different teams? So that's really, what we're seeing in terms of where customers are today in the struggle with managing data. Next slide, please. So ultimately, how we approach solving this problem is by converging the benefits of both data lake and data warehouse into what we call Lakehouse. So the benefits of the data lake being all the data lands in one spot, high density, low cost storage. Benefits of data warehouse is around performance, reliability, and governance. So you now have the ability to run BI-like workloads from your data lake, as you'll see in a demo later on. So by combining the best of both worlds, the Lakehouse architecture becomes that unified analytics platform for your data analytics and AI workloads. Next slide, please. So the way we accomplish this unification is through Delta. Delta Lake is it's an open approach to bringing data management and governance to the data lake. So performance and reliability are done through ACID transactions, indexing, schema enforcement, and giving the data lake a similar experience as to what you would see from a data warehouse. So we can then apply governance through fine-grained access control lists as well. I don't want to steal Andre's and Sebastian's thunder, so with that, I'll stop here as they'll provide some more details later in the presentation. So as mentioned earlier, the goal of unifying the data analytics platform is to have one common architecture for all your use cases. So starting from the bottom and working your way up, the first thing to point out is we're cloud agnostic. So whether you're on one cloud or multi-cloud, the architecture doesn't change. So all the data now lands in the cloud and that becomes your single source of truth. The Lakehouse platform leverages Delta to provide data management, reliability, and governance in making that data available to the different personas. So again, not having to have those separate architectures or stovepipes to deliver data to the different personas. So Delta is a medallion approach to refining and processing data. So picture raw data coming in, landing in a bronze zone or bronze table. This could be passed to real-time streaming users doing anomaly detection. Next, you could be doing some further refinement from your bronze table to silver. That might be used by data scientists and machine learning engineers to work on predictive models. And then additional further refinement and processing from silver to gold that would allow business analysts to have access to data in the format that allows them to do their traditional reporting and visualizations. So really, the goal here is simplifying the overall architecture, one single source of truth, a processing layer that sits on top of that data lake that now allows each of the personas and business units to get access to the data in the format that that they're most used to. So simple is top priority, but being open is as well. So as mentioned earlier, we're driving a data ecosystem with open source standards and formats. We continue to innovate with some of the most successful open source projects in the world. I mentioned Delta. Another great example is MLflow, which is as I said, downloaded 2.5 million times a month. It's an open source platform to manage machine learning lifecycle, including experimentation, reproducibility, deployment, and a central model registry. We've also got things like Koalas as another example, which provides drop-in-place replacement for pandas, commonly used by data scientists. Pandas is a Python package that provides easy-to-use data structures and data analysis tools, but oftentimes the issues around scaling. So really, again, continue the innovation, open source, open platform, and delivering value to our customers. So open also includes interoperability with the hundreds of partners in the ecosystem. So on this note, we just announced a partner connect where essentially what we're trying to do is simplify the integration and reduce the number of clicks it takes for interoperability between these products. And so we're continually pushing the envelope in terms of creating that open, simple, collaborative platform. You see here, there's a large list of ever-growing point solutions and integrator partners that we're working with to help customers accelerate those outcomes and reduce complexity, which is where we're starting from. So again, always pushing that simplicity, but open as well. So finally, we talk about collaboration. It's worth mentioning the Lakehouse platform allows for different roles and personas to collaborate and share their models, dashboards, notebooks, and data sets. So as we mentioned earlier, the platform removes silos between teams, allowing for reproducible results and scaling success across the organization. I can't tell you how many customers I work with where individual lines of businesses are doing identical projects in parallel and they don't know about it, right? And then there's also the how do we reproduce results? How do we go from ideation to production in a timely fashion, and then make that reproducible across the organization? So in summary, we're simplifying the architecture, we're making the data more reliable and performant, allowing teams to collaborate seamlessly. The Lakehouse architecture not only unifies the data and analytics and AI, but it democratizes the data so organizations can truly become data-driven, which is really what we're trying to drive towards. So I think my time is up. So Andre, I'll pass it over to you again. Once again, everyone, thank you for your time.
All right, thanks, Rico. So that brings us to the topic at hand today, which is why SQL? An SQL interface was the #1 requested feature by our users over the past number of years. So to have a simple, easy to use interface that's familiar to most business intelligence users was of prime importance to Databricks to get off the ground. And the main goal there was to make data a democratic process, is to make it available to all enterprises to drive innovation and to really level up their data game, given the fact that organizations at N21 are highly focused on those data-driven decisions to drive the outcome of the business. So here to tell you a little bit about Databricks SQL, I'm going to pass it over to Sebastian.
Thanks, Andre. Yeah, so like Rico mentioned earlier on, right, we currently have the parity between two systems, that is the data lake and the data warehouses themselves, right? Data lakes themselves are really, really good to hold a bunch of data for very, very cheap costs. And data warehouses, on the other hand, are very, very good in being queried very fast, right? The problem is some of them, both sides have really, really good things, but working together a lot of times is pretty hard, right? What that results in is us having and we had mentioned this before, a ton of siloed data and teams, right? A data warehouse itself is purpose-built. That means that different departments within a company might have different data warehouses, right? And what that means is that we have copies of the same data everywhere within organizations. We oftentimes have clients come to us asking, how do we make sure that we have one single source of truth, right? And that's really where Databricks SQL can help us here, and we'll get into that in just a second. But what we really need here is trying to figure out how we can utilize the best of the data lake and the best of the data warehouse, right? Right now, organizations have thousands and thousands of pipelines in order to make sure that the data that they've taken out of the data lake is well curated and put into a data warehouse to be queried there. And that results in huge investments, right? But also doesn't ensure that the correct data is always there, right? Because we have so many of those different silos going on. In turn, looking at the Lakehouse architecture, we are going to solve that. So in the middle here, looking at the Delta Lake layer here, right, in between the data lake that we have, so all of our data coming in from all of these separate systems. We needed a way in order to structure it, right? We know that a data warehouse is really, really good at structuring data. It is good in order to make sure that we can do all of this SQL things that we like doing, right? We needed to figure out a way in order to make sure that everything that comes in is coming in the way that we want it to, right? So we have to do less work with the data. And that being said, all of this was built by Databricks on an open format and architecture. And the Delta Lake architecture definitely enables us to do SQL things such as adhering to ACID transaction, right? Indexing, fine-grained control, as Rico was mentioning, right? Schema validation on the data lake itself, rather than having to wait for it until it hits a data warehouse, right? Way at the end of that pipeline. What that results in is having that constant ETL going on in the Delta Lake side makes it a lot easier and a lot quicker for us to query that data and getting that data out to the business intelligence tools of your choice, or having your end users use the SQL workbench that Andre will talk about here in a minute. And that way, we are now able to streamline this entire process, right? At the end, again, with the goal of enabling data-driven innovations to all enterprises.
So
Next.
on that note too, I think it's also worth mentioning that running SQL on files in a data lake is nothing new. There are other platforms and solutions that do that. What is new, however, is being able to do that with a certain amount of integrity and a transactional nature, and that is huge. So historically, like if we roll back the clock about 5 minutes when Seb was talking about the difference between warehousing and data dumping, essentially, what we're doing is we're adding an element of structure on top of the data lake that does not require our users to ship off, make a copy of the data, and thus adding not only complexity, but volatility to the data, which is the biggest enemy of data and AI management today.
And
there we go.
And in addition to that, here's exactly what, Andre, what you just talked about, right? Our very common challenges with the data lake, right, were reliability, performance, governance, and quality. And if you look at the bottom half here, right, with the Delta Lake, we finally have those ACID transactions, right? The indexing, the role-based access control, or the access control list, however you want to govern it, right? And of course, the schema validation that you mentioned. To structure a data lake, there's many different ways you can do it, right? With Databricks, of course, we're talking about the medallion architecture, the bronze, silver, and gold. And what that essentially means is, depending on the state that your table is in within a data lake, you can give it a different description. So a bronze level might be just, this is where we're going to put all of our raw ingestion data and keep the historical versions of everything, right? And that's really all the bronze layer provides. The silver layer, we'll clean it up, right? Maybe we decide to change column names. Maybe we need to convert an integer to a double, whatever is needed in order to get that table to the silver version. And for some use cases, the silver versions are perfect, and that's completely fine. If you want to add a little bit more of the business layer on top of that, maybe you have a table in the gold layer, and that could be a couple of silver tables combined into a gold table. It could be just a single silver table with a bunch of business logic over top, and that'll be a gold. But then also don't feel restricted to only 3 levels here, right? There's organizations that we have seen that have 4 or 5 different layers. It all depends on what your business use case is and what makes most sense to your organizations, right? And Andre, if you want to add a couple things to that, feel free to.
Yeah, and I think you kind of actually already touched on some of the ideas there, but having some type of structure to that evolution isn't only really a good idea for the actual data, like the payload itself, right? It's also a good idea to consider the structure, the schema, the metadata evolution. So typically when I go through this process, I actually stick pretty close to this 3-stage model because for the use cases that I'm working with, I don't tend to, go too far out, but it's not uncommon for me to work with folks that might have 5 or 6 levels of evolution. And if you think about it in context to normalizing database structure, it's very similar to that. So as we go from first to second to third normal form, for example, that's essentially what we're doing here.
Mm-hmm.
The difference being is that we're not isolating the data chunks, we're instead refining it and actually making it cleaner to use. We're not going to talk so much about data and delta sharing today, but what's important about it is as you go through this data evolution process, that data now becomes consistent and reliable, not just for the analysts, but for the data scientists and for the engineers as well.
Definitely take away that we can start thinking of Databricks and the Lakehouse itself. You can start treating that as any other database within your system, right? Having the ability and having decided to make SQL a first-class citizen, Databricks now is definitely a lot more approachable to some of those third-party tools, right? Whatever you use in order to write your SQL queries, you can use. Of course, we can use third-party BI tools as well, Tableau, Power BI, Looker. All of them are able to query data that sits on the Lakehouse, right? So definitely think of use cases that you might be able to now attack with SQL being a first-class citizen on Databricks. There it is, perfect. And with being a first-class citizen, we need to, of course, have a first-class SQL development experience, right? Like Andrew said, this was the most requested feature of Databricks, so Databricks delivered, right? We now have the ability to, within Databricks, use the SQL workbench that was built, and Andre will show you a couple examples here in a minute, but definitely think of it as very quickly querying the data. It doesn't matter what state it is in, right? And very, very importantly, you as the end user, you need to know SQL. You will not need to interact with Spark here. Databricks decided to abstract that away from you, right? So that we are just going back to our good SQL roots here and do the way that we have always worked with the data, right? Writing SQL queries. So it is a very, very cool feature that's now available. And with that, I will hand it over to Andre.
Awesome, thanks, Seb. Yeah, so as Seb mentioned, Databricks is predicated on the Spark runtime. So everything that we do in the context of data analysis is all built on Apache Spark. I can't recall if Rico mentioned it or not, but Our founders at Databricks were the original developers of the Apache Spark project at the UC Berkeley Amp Lab, which is kind of cool. So if you're looking for the latest, greatest, fastest version of Spark, come to Databricks. So what I'm going to show you guys here is, there we go. So real quick, what we've done in order to bring SQL forward to the forefront of the interaction experience is we've actually created a new view and a new interface to work with SQL analytics. So here you can run everything from a dashboard, do some query analysis, create some alerts, just view your data and metadata from the Hive meta store, manage your SQL endpoints, and also have some auditability with query history. So just for the uninitiated, SQL endpoints are really just Spark clusters with a very specific focus on running SQL code. And we've got some really cool advanced features with SQL endpoints specifically. So first of all, sizing is very easy and very straightforward, regardless of whether or not you're running on AWS or Azure. We have standardized these clusters into general t-shirt sizes. You'll notice on the right of the cluster size, it gives you a DBU estimate. So SQL Databricks units are actually cheaper to run than interactive general purpose compute clusters. We've got certain features which are, add to quality of life, things like cluster tagging, which is really good for audits, chargebacks, or anything along those lines. Auto shutdown features to help you manage costs. But my two favorite features that are unique to SQL endpoints, one is Photon Engine, which basically takes whatever query you're writing in SQL, auto-optimizes it, and vectorizes it. So no longer do we require our users to be experts in multi-thread parallelization across a Spark cluster. That sounds fancy, but all you need to do in SQL endpoints is just flick that little Photon button that you see at the bottom there. And the other thing we offer is on-demand serverless in AWS right now, coming soon to Azure. So that's kind of cool. SQL queries. You've got this new tabbed editor, which is really easy. On the left here, what you see is the Metastore browser. Just select the endpoint that you had just created. And what happens as a result of this is you have an interactive live view of your queries as they're being run. So you have things like code completion, you've got table evolution, you can actually do a sort by column without actually having to type anything. So working with this is going to be second nature for any of you guys that are already familiar with any type of SQL workbench. Queries themselves support full TSQL syntax highlighting, which is pretty awesome. After you've attached to a SQL endpoint, you have nice features like auto code completion to limit and mitigate the, trust me, I fat finger a lot of stuff. So eliminating that actually makes me work faster, which is something I'm very fond of. Resource introspection, which basically means there that anything that's in scope and available, so external libraries, peer queries, anything along those lines is going to be available through that IntelliSense code completion. And one thing that is kind of unique to the SQL workbench is something called field parameterization. So that's where when you're working with a table or visualization, which we'll get to in a minute, you can actually have user interactive features. So things like open field text boxes to refine searches, drop downs to limit end users to lock them into certain mutations or pivots of a given view. Little quality of life things like that that are really, really cool are available from minute one when you start working with SQL queries in the analytics workbench. Visualizations, dead simple. As long as you've got a table represented at the bottom of your query, it can generally be visualized very easily and very straightforward. Now, we do support static or scheduled runs on these, but we also now support streaming updates to those visualizations, which is probably one of my personal favorite features. So I'm a big fan of structured streaming, and we actually support visualizations that update live. They are exportable to PNG, PDF, or even to, I believe now we also support iframe exports, which is cool. And our visualization support multi-series modes. It really enriches the bounds of the visualization. Dashboards, probably once all this is said and done, the thing that we're ultimately attempting to build here. We have a custom dashboard interface. You can bring in any visualization or any table that you've already created and apply global parameterization to those visualizations. So a common thing that folks will do there is date and time constraints as an example, or if they've got a group or logically grouped data, that's another good option for a dropdown. If you want to, for example, run dashboards with elevated privileges and you have it configured, Databricks offers an option to run dashboard panels as an assumed user. So if you've got someone, for example, that has a very specific query that returns a very specific visualization for data that might not otherwise be available to given consumers of that dashboard, you can run that dashboard and even down to that panel as the creator of it. So it really eliminates the need for some fancy table level access control. You can directly export query windows straight to your dashboards. And once they're created in the query editor, they can actually be reused several times to different dashboards for many different users. And like I mentioned a moment ago, because it's all ACL managed, not only can you have certain panels rendered or not for given users, you can have subsets of information that are factored in for different users. So what I mean by that, for example, is if you have companies A, B, and C, for instance, and John Doe doesn't have access to view data from company C, he'll see panels only rendered with data from companies A and B. So as far as the usability of it's concerned, like we adopted this whole drag and drop interactive, type experience. That's kind of de facto standard for dashboarding utilities in 2021. We support independent linear logarithmic scales, custom colors, so you can corporatize the dashboards with your corporate colors. And then also two enrichment panels with HTML or just standard Markdown syntax are both fully supported, which is awesome. Getting into, sorry, I'm just gonna do a quick time check here. Okay, cool. So just one of the cooler features that I personally leverage a lot is this query history. So not only is it gonna show you what's been run in the past, but how did it run? What are the parameters? What is Spark doing under the hood to execute this query? Which is pretty awesome because it kind of breaks down everything around the execution plan for you, so you can actually see how the Photon auto optimize engine, for example, is actually splitting up the queries and running them, which makes it really easy to troubleshoot long running queries. We offer connection properties, so they're easy to locate. Yeah. So these particular connections running from my cluster that you're seeing on the screen here probably won't work for you guys because I've expired the tokens already. But the point is, they're easy to find. And the reason why we format it this way is because it makes it easy for you guys to interface with it through standard JDBC, ODBC connections for anything of your choice. Like Seb mentioned, we integrate well with like things like Looker, Fivetran, Power BI. Tableau, but I've also managed to use this particular interface to hook up to time series dashboard platforms like Grafana, for example. We support full connection pooling and default to transport layer security. For any of you that really have questions about security mindedness, all of the transportations are done in server-side encryption. So last but not least is BI tools integration. I just kind of thrown together a very quick demo for you guys here on how easy it is to take those connection properties that I had just shown you, plug them into Power BI, and very quickly and securely start working with the data in the context of something that might be a little bit more familiar to the business analyst. Like I mentioned, Power BI and Tableau are kind of the two big ones that we're seeing right now, with Looker from Google being another popular one that we're seeing better adoption for more recently. Now you may ask yourself, like, what's the difference between import and direct query? It's whether or not you're caching all of the data from any of the databases that Seb alluded to earlier, so like the bronze, silver, gold. Personally, the data sets that I work with are usually too large for direct import, and it will just cause my workstation to crater. So I tend to prefer the direct query method. It's a little leaner on transportation, and it's all predicated on the data living in Databricks or on your data plane as a customer, and then simply just pulling in the aggregations, the factors, the metadata into Power BI to do that reporting. We've got many more integrations, and more info for that can actually be found in publicly available documentation on docs.databricks.com/integrations. So with that in mind, that is pretty much an end-to-end example of how you interface with Databricks SQL. So that actually wraps up the demo today. So I'm just going to stop here for a second. I'm going to ask Catherine if you can come off mute, and if there are any questions from folks.
Hey there, yep. So we did have a question from Dylan. He said, looks like a serious alternative to Azure Synapse, and was wondering what other options are available if they wanted to create a data lakehouse in Databricks, but would like to create the tabular model in Azure Analysis Services or Power BI Premium.
Okay, yeah, and that's actually a really good question. The quick answer is yeah, 100%. Like, you can take any level of data evolution and apply it. We have a number of customers that actually pre-factor all of the raw data in Delta, so the Lakehouse framework. And then to reduce costs, we'll actually use that as a source to Synapse. So they'll actually treat Synapse as the ultimate sink for the resultant tables in Databricks.
And in addition to that, Dylan, to your question, right? Analysis services, Power BI Premium, they all can utilize, and Power BI Premium just through the desktop, of course, can utilize ODBC connectors, right? So as we talked about beforehand, with SQL being a first-class citizen, both of those tools are able to, of course, access the data that is sitting on the data lakehouse, no problem.
Awesome.
Well, there was a part 2 to that question, which is the Metastore available to external applications?
I believe it is. I'd have to actually check into that for you. So maybe if you have questions about the Metastore specifically, you can reach out to Catherine or myself, and we can do a little bit more digging with that. Like I said, I believe it is, but I mean, a lot of that depends on what restrictions and implications are set up. Because it is your data, I have every reason to believe it is, but truth be told, most customers rely on consuming the Metastore from within the Databricks ecosystem.
We'll get back to you, Dylan.
Yep, and I'll just,
Yeah.
sorry, I was just going to add on to that. So generally speaking, yes, but depends on the actual specific scenario that we're trying to solve for. So maybe if there's a clarifying question on there, feel free to add it, or we can also take that offline and follow up on that conversation.
Okay, and I see there's one more question from Alexis that just popped up. It said, is the Databricks Lakehouse platform, is it a platform as a service? It's actually software as a service, really. Now, the way that works is customers maintain their own data plane, and Databricks just works on top of that data plane. So any resultant files are best actually stored within your own domain. So the precept of everything that Delta runs on is actually managed Parquet, and those Parquet files are just still stored in whatever storage platform is of your choice. Is the Lakehouse deployed in cloud providers or best deployed in a preferred provider? We support all the big three, so Azure, GCP, and AWS. And Rico, I'm going to ask you, we support, what was the other one? The one in the
Alibaba.
Yeah, that's the one.
Alibaba.
I wanted to say Alibaba, but I also know they're like a commercial market. I didn't want to come off sounding like that anyway.
It's kind of fun to say, but yeah, so to kind of elaborate a bit further and then to answer on Alexa's question about whether there's a best deployed one or a preferred, I think this answer will vary, but first it would depend on what the organization has a preference towards. So some organizations will view AWS, for example, as a competitor, so they'll avoid anything Amazon at all costs. But we're also finding that a lot of customers are choosing to go multi-cloud as well. So that's certainly an option as well. And then there's various pros and cons of working with AWS versus Azure. It's kind of a bigger conversation. We're happy to have it, but I think starting with what your organization particularly prefers, and then kind of digging down into the details of various nuances and pros and cons of each one.
Yeah. All right. Well, I wanted to thank everybody for their time. I wanted to thank especially the Newcomp folks for hosting us and giving us a venue to share Databricks SQL with everyone. So that in mind, I'm going to go on mute. Thank you, everyone, and I'll give the rest of the folks a chance to say the quick thank you.
Yeah, thanks everybody for joining. Hope you took something great away from that. And if you have any more questions, you know how to find us.
Yeah. I was going to say the same thing. Thank you, and please don't hesitate to reach out. And certainly, if we don't have the answers, we'll get them for you. Have a great day, everyone.
All right. Thanks, everybody.
All right. Bye-bye.